So now we're going to start. What we did last time was that we talked about naming organic compounds, and this is what we had learned. Okay, I told you that carboxylic acid, the suffix is oic acid. There's a bute if it has 4 carbon atoms. AN or EN, that's the middle part. If there's a double bond, it's unsaturated, that would be an EN. And you would have to give the position of the groups that are involved. The most important group, you count from the most important group, which in this case would be, you're going to count from this side. This would be 1, and the double bond would be at position number 3. The same was the case with aldehydes and ketones. Aldehydes, the name would end with Al. It's 4 carbon atoms, it's bute. The middle part, AN or EN. In this case, it's a saturated molecule. No double bonds, so it's going to be AN. You had a ketone over here, which was 5 carbon atoms pent. Ketones end with one. And the middle part would be EN in this case. You're going to count from the side, from the right side in this case. The double bond is at position number 1. The ketone is at position number 3. So the molecule had 3 parts. It had a prefix, it had a suffix, and it had the middle part. And we did all sorts of suffixes. We did alls, we did enes, we did anes, we did all sorts of suffixes. And the middle part is where you would put in whether it has a double bond between the carbon atoms or not. Now, what we're going to do is we're going to talk about multiple functional groups. What if a molecule has many functional groups? In that case, precedence or the importance of the group is going to matter a lot. So you've got alcohols, you've got amines. Now, the most important group, the double bonds come after that. They are the least important part of the molecule. And even less important than double bonds, that's your alkyl or carbon chains. So you've got alkyl chains or your halogens. So every group has a certain importance. And carboxylic acid, the carboxylic acids, they are the more important. I mean, they have the highest importance in the whole family of organic compounds. It's just when it comes to naming, I mean, there's no real importance. It's just that when you're naming compounds, carboxylic acid will have the most important. So the first thing is the suffix, the main suffix or the ending part depends on the highest precedence group. So the suffix is determined by the highest precedence group. So what are these suffix? If it's got a carboxylic acid group, it's going to be oic acid, and so on. If it's an aldehyde, it's going to be Al. If it's a ketone, it's going to be on. And if it's an alcohol, it's going to be all. For amines, it's going to be just an amine. Double bond is going to be an ene, and so on. Now, the top 3, the first 3, they always remain a suffix. Like no matter what, they would be named at the end of the name. I mean, the name would always come at the end, the first 3. And I'm going to explain how. So the first 3 are always a suffix. And these 2, what will happen to them is that if a higher precedence group is present, then they would become branches. So in the presence of a higher precedence group, and I'm going to explain this all with an example. If a higher precedence group is present, then they become a branch. So your OH group would be called a hydroxy branch. And your NH2 group, which is an amine, that would be called an amino group, just like in amino acids. So it would be called a hydroxy group or an amino group. So now let me explain this with all of this with an example. So let's start with this molecule that has multiple functional groups. So it's got a double bond at the start, and it's got these, let's say, 5 carbon atoms, and it's got a carboxylic acid. And it's got a ketone as well. It's got a double bond over here. And what else? That's it. And there are hydrogens attached. This one will have 1 H, this one will have 2 H's. So if I have this molecule, it's the prefix would be based on the number of carbon atoms. That's 5 in this case. So it's going to be pent. The middle part, AN or EN, would be, it's going to be EN. That's going to be EN because it's got a double bond. And what else? The suffix of the molecule, it's got 2 groups. It's got a carboxylic acid. It's also got a ketone. Remember, a ketone is where the serial bond O is somewhere in the middle of the chain. It's got carbon chains on both sides. That's what a ketone is. So this one is a ketone. If you look at this molecule, it's a ketone. It's got a serial bond O somewhere in the middle of the chain, and it's got a carboxylic acid. So I told you that the suffix depends on the highest precedence group, which in this case is the carboxylic acid. So you're going to call it an oic acid. So it's going to be referred to as an oic acid. That's the suffix. That's the main suffix. But at the same time, it's also a ketone. So this part is oic acid, and this part shows that it should be a ketone as well. And I told you that a ketone always remains a suffix. So you're going to add all the other suffixes in the middle as well. So this is a ketone. So I'm going to put in -one as well, just before the oic acid. We're going to put that in as well. So it's got 2 suffixes. The main one is the carboxylic acid because it's got the higher precedence. So the whole molecule is named after that one. But it's got a ketone as well. So again, I'm going to add in this extra suffix as well because it always remains a suffix. Is this clear up to this point?
Yes.
Yes.
So, and the next thing is you have to give the position of each one of the groups. And remember, counting is done to give the smaller number to the higher precedence group. So you need to give a smaller. So you don't care about all the other groups. You just care about the higher precedence group. Smaller number should be given to the higher. Which is why we're going to count from which side? We're going to count from the right side. The carboxylic acid is the most important group. So this is 1, this is 2, this one is 3, and 4 and 5. Right? So that means the carboxylic acid is at position number 1. You don't need to write 1 in most cases. And the ketone is at position number 3. And the EN, the double bond, is at position number 4. So that's how you're going to name the molecule. It's going to have 2 suffixes. An one showing a ketone and an oic acid, which shows that it's a carboxylic acid. Is this part clear?
Yes.
Yes, sir.
Okay, so that's one thing. So the first 3 always remain a suffix. So even if you have multiple functional groups in the molecule, just keep adding the suffixes. The main one would be the one that would be at the top. Now we're going to come to this. When it comes to alcohols and amines, what happens is that if a higher precedence group is present, then they become a branch. What does that mean? So this is how branch molecules are named. Branch molecules are named in this order, that you have the main molecule, and so that's known as your main chain. We're going to discuss the main chain later in a lot more detail as well. And before that, you're going to write the position of the branches. So that's how you, okay, let me just discuss branch molecules as well. But let's keep that discussion right after this. Anyways, branch molecules, right now we're just doing straight chain at the moment. So that's your main chain. Branches are attached to that main chain, and you have to give the position of the branches. Like at what position are the branches attached. So let's do one where an alcohol is involved. So one example is, if I have this molecule, it's got a ketone, and it's got a double bond as well, and there's an OH over here, and there's an OH on this side, and a CH2, and let me add, this one will have one H, and let me add an amine as well, and this one will have two H's. So it's got lots of functional groups, but so starting with the first thing, the total number of carbon atoms that you have, that's 5. So the molecule will have pent at the start, and it's got a double bond, so it's going to have, instead of the AN, it's going to be EN. Now, which one is the most important functional group over here? It's got a ketone, so that means the suffix should be -one. It's got an alcohol, the suffix should be -ol. It's got an amine as well, so the suffix for an amine should be amine. So it's got 3 suffixes, but which one is the most important one? Based on ketones, alcohols, and amines, it's ketones that's the more important one. That's got a higher precedence. Is that part clear?
Yes.
Yes. Yes.
I said, so the molecule is going to be named after, I mean, it's going to be called ON. And it's going to be named after this thing, this ketone group, because that's the most important group. And you're going to count from the side that gives the smaller number to this most important group, which is ketone. So you're going to count from this side. So this is 1, this would be 2, this is 3, 4, 5, and that's it. So you're going to count from the right side, and the double bond is at position number 3. And the ON is at position number 2. Now, what happens to all? I told you that an alcohol, if a higher precedence group is present, it becomes a branch. You start considering it a branch, and this would be known as a hydroxy branch. So you would no longer consider it a suffix. This is what we wrote down, that if a higher precedence group is present, then they become a branch. So you've got OH, you've got NH2, they're going to become hydroxy and amino branches. So in this case, that's a hydroxy group that's attached over here. There's another hydroxy group that is attached over here, and there's an amino group which is present over here. So what you're going to do is you're going to write all the branches in front of it. So you've got 2 branches. So this is your main molecule, the main chain, and it's got an OH branch that is attached to carbon number 1. It's got another OH branch that's attached to carbon number 4, and it's got an NH2 branch, which is the amino branch. So we're going to write the branches in front of this. So the first one is amino, and you've got a couple of hydroxy branches. So that's how you're going to write the branches right in front of the molecule. And once you've written them, you have to give the positions. Now, hydroxy would become dihydroxy because there are two of them, right? So you can either write hydroxy twice, which would just consume a lot of space. Dihydroxy is better. That will just tell you that there are two hydroxy branches, and there's one amino branch, and you're going to give the position of the amino is attached at carbon number 5. So this is going to be 5 amino, and the hydroxy branches, the OH branches, are attached at carbon number 4 and carbon number 1. So you're going to write 1,4 dihydroxy pent 3-ene 2-one. And that's how the molecule is going to be named. That the branches are written right in front of that. And the branches are written in an alphabetical order. Like amino comes first. And hydroxy comes later on. So is this example clear, this one?
Yes.
Yes.
Rima, is this clear?
Teacher, can you
Yes.
repeat the amino hydroxyl part?
Okay, I'm just going to repeat the whole thing very quickly. First thing, the point was that if you have an alcohol or if you have an amine, and there is some group that is present that's more important, has a higher precedence compared to the other ones, right? So these would become branches. The main molecule is not going to be named after them. They would be considered branches. And branches would be written in front of the main molecule, like whatever the main molecule is. So you had 5 carbon atoms. The main molecule was pent. It had a double bond, so it was, instead of AN, it was EN, and it was a ketone, which was more important. So the name of the molecule was based on the ketone functional group, which gave it ON at the end. And you had to give the smaller number to the most important group, which is ketone over here. So this is 2. And that's how you number all the other carbon atoms. So the double bond is at 3 and the ketone is at 2. Now, the OH used to be an ol. I mean, whenever you had an OH, you just put an ol suffix at the end. But now what you're going to do is you're going to call it a hydroxy branch. So there's an OH that is attached to carbon number 1. There's an OH branch that's attached to carbon number 4. And there's an NH2 branch, which would be now called an amino branch instead of an amine. And that would be attached to carbon number 5. So you've got a hydroxy branch. So branches are written in front of the main molecule. So you've got a hydroxy branch, you've got an amino branch. And since you have 2 hydroxy branches, you would call it dihydroxy. That means 2 hydroxy, like carbon dioxide. So dihydroxy means 2 hydroxy branches. There's a single amino branch, so that's it. And you write down the position at where in the main chain are they attached. So the hydroxy branches are attached at carbon number 1 and carbon number 4. So it's 1,4 dihydroxy. And the amino branch is attached at carbon number 5. So that's going to be 5 amino. Is that clear?
Yes.
Yes, sir.
Sir,
Yes.
let's just suppose if there was a carboxylic group, so we just write what do we say, OH at the end, and then whatever carbon the carboxylic group was attached to.
Yes. I mean, if there was a carboxylic acid, the on would remain a suffix, because I just told you that the on always remains a suffix. You're just going to add the carboxylic suffix next to it. I mean, that would be your main suffix, and the other suffix you're going to put in between. Is that clear?
Yes, sir. Thank you.
I mean, we can do another one where we have let's do simpler ones. We've got 3 carbon atoms. It's got a carboxylic acid group on one side, and it's got an aldehyde as well. and there's an OH that is attached to the middle carbon atom. Now that's the molecule. It's 3 carbon atoms, so it's going to be prop, and it's going to be AN. Why? Because you don't have any double bonds, so it's going to be AN. And now it's an aldehyde as well as a carboxylic acid. So carboxylic acid is more important. So you're going to count from this side. This is going to be 1, this is going to be 2, this is going to be 3. So the carboxylic acid group is given more importance. And that's the main functional group. So it's going to be oic acid. But at the same time, it's also an aldehyde. So the aldehyde also remains a suffix. So you're going to call it an AL as well at the end. So it would be AL and then oic acid. And you can give the positions for 1, you don't have to write 1, but the aldehyde would be at position number 3. And you've got an OH as well. That would, because you've got more important groups than OH, that would be considered a hydroxy branch now. So instead of naming the molecule after that, you would call it a hydroxy branch. And that would be written before that. It's there's only one hydroxy branch in this case, which is attached to carbon number 2. So that's the overall name of the molecule. And it's going to have 2 suffixes. It's going to have oic acid as well as it's going to be an aldehyde as well. Is this clear?
Yes.
Yes, sir.
So let's do one more example. And I'm keeping the molecules straight chain molecules at the moment. So I've got OH groups attached and double bond, and there's NH2, and let's have 1H with this 1H. This one will have 1H, this one will have 2 H's. Actually, now this molecule, first thing, quickly tell me, anyone, what's the prefix, like how many carbon atoms?
Pent.
So it's going to be pent followed by AN or EN.
Ian.
Ian.
So now which one is the most important group in this entire molecule? Is it the amine or is it the OH? What? I mean, like which one is it? It's
the OH.
Okay,
OH, yeah.
so the alcohol is more important compared to amine. So it's going to be an all. So over here the OH doesn't become, but the amine becomes an amino. It becomes the OH would remain all, but the amine would now be called an amino group. So it would be called an amino group. So the main suffix in this case would be all. So the OH does not become a branch. It remains all, because there's no one more important than OH in this molecule. So it remains all. And therefore the NH2 becomes a branch. And that would be called your amino branch. Now, which side should I count the molecule from? Right side or left side?
Right.
Right.
Okay, so I need to give a smaller number to the OH group, and also it's a diol because there are 2 of them. There are 2 OH groups, so it's a diol, and the positions of both of them, one is at 1, the other one is at 2. This is 3, double bond at 3, and the amino group is at 5. So this is at 5. The double bond EN is at position number 3. And the 2 OH groups are 1 and 2. So it's going to be at 1 and 2, and it's going to be diol. Because that's the name of the molecule. So is this clear?
Yes.
Yes, sir.
Yeah.
I just now moving to the last one, and I'll quickly draw the skeletal formula as well. Like it's 1, 2, 3, 4, 5 carbon atoms. So 1, 2, 3. That's 4. This is so it's 1, 2, 3, 4, and 5 carbon atoms, and there's a double bond over here on the between the third and fourth, and over here there's an OH attached on the first one on the right, and an OH attached on the second one on the, and there's an amine that's attached at carbon number 5, so it's attached over here. So that's the skeletal formula of the molecule. So now what the last thing about naming. Okay, and again we don't have to spend. Naming is important. Remember, I told you okay, what's going to happen is that direct questions would be very few, and they would at best be for 1 mark. But the entire question sometimes is dependent on the name of the molecule. So you need to know what the structure is. Now, the last thing that we're going to discuss is this thing in detail, and we're going to talk about branched molecules now. So remember, we already discussed that its position, branch and positions are written right in front of it. And then you have the main chain. And the main chain is, it's going to have, so now this is basically your complete naming now, TK. What we're going to discuss is, we're going to bring everything together. So you have prefix, which is, so the main chain is prefix, middle part is AN or EN, and the end part is your suffix, which is going to be based on the most important group, the highest precedence group. So that would be based on the highest precedence group. Now, how do you figure out the main chain of a molecule? The main chain is decided by, it should be the longest possible carbon atom chain. Okay, that's what your main chain is. It should be the longest possible carbon atom chain. But, and remember, longest possible. It must not be the longest possible. I mean, even if it's not the longest, it's still fine. It's the longest possible carbon atom chain that meets the following criteria. Like it should have the main precedence or the highest precedence group in it. It should have the highest precedence group in it. Like if a molecule has a carboxylic acid, then the main chain, the carboxylic acid must be a part of that. It should have the maximum substituent groups, or what we mean by substituent groups are maximum number of functional groups attached to it. And it should have the maximum double bonds in it. So it should have the maximum double bonds in it. So as an example, like how do you decide a main chain? Now we're talking about a branched molecule. So I have a molecule, and let's say this is the molecule, and it's got 2 carbon atoms over here. There's a double bond, O and OH attached. Let's say there's a double bond here. This is an OH and there's an NH2. All these groups are attached, and you can add in the hydrogens. So this one will have 1H, this one will have 1H with this one, 1H and 2 H's, and this one will have 2 H's, and this one will have 3 H's. So I have this molecule now. So first thing, I'm just trying to figure out which one is the main chain. So it should be the longest possible carbon atom chain that meets the criteria. So one criteria is this one, that this is your main chain. Like it's and it should not be a straight chain. It could be a zigzag or a bent chain, but it has to be a continuous chain. So that's your longest possible carbon atom chain in this molecule. It's 1, 2, 3, 4, 5, 6, and 7 carbon atom. That's the longest possible carbon atom chain. Now, based on this criteria, should I consider this as my main chain or not?
No,
Again, why not?
because it doesn't have the high pressure group.
Okay, so the highest presence group is not part of that. The carboxylic acid, this carbon is not a part of this. And I told you that it should be the longest possible carbon atom chain that should include the highest presence group. So I'm not going to take that as my main chain. Is this point clear?
Yeah, yes, sir.
Yes.
So it should have, so I'm not going to consider this as my main chain. What I'm going to do is I'm going to go for a smaller chain. And I'm going to consider this as my main chain. Why? Because at least the highest presence group is now a part of that. And it also has the maximum substituent groups and the double bonds as well. Like the NH2 is also a part of that. The OH is also directly attached to it. The double bond is also a part of that. So it should have the maximum groups that are attached to it, including the highest presence group. That's going to be our main chain. Is that clear? This thing.
Yes, sir.
Yes.
I said then for branches, we already discussed about branches that who becomes a branch? The OH. I mean, this is conditional if a higher presence group is present. So if a higher presence group is present, then what's going to happen is that I mean, we already discussed OH becomes hydroxy, and NH2 would become amino. Then there are two more. You've got these alkyl chains. Alkyl chains are your carbon side chains, and the name would end with while. So, for example, if it's CH3 that is attached, that's methyl, because it's meth followed by while. If there's a carbon branch with 3 carbon atoms, then this is going to be ethyl, right? Not ethyl. 3 carbon atoms is prop, and it's going to be prop while, so propyl. So you've got your alkyl chains. Then also you will have you'll have halogens. Halogens are always considered as branches. So halogens would be like if you have a halogen, it's going to be like chlorine would become chloro. Bromine would so on become bromo. Iodine would become iodo, and so on. So these would be your branches as well. So remember, if so all the other things would be considered branches that are attached to the main chain. And position we've already discussed, like which side do you count? You give the smaller number to the highest precedence group. So smaller number to the most important group. So anyways, coming back to this. So I figured out, so I mean, the molecule is going to be named, the main chain would be named first. And its suffix would be decided by the highest precedence group. In this case is a carboxylic acid, right? So first thing, naming the main chain, how many carbon atoms? It's what's the prefix for this one?
Hex.
And Oh, hex, sorry.
hex. Okay, that's hex. And there's a double bond, so it's going to be ene, and it's the carboxylic acid, so it's going to be oic acid, right?
Oic acid.
And you're going to count from this side. This is 1, this is 2, this is 3, this is 4, and this one is 5, and this one is 6. So you're gonna count from the left side. Anyways, it's hexanoic acid, and we'll put in the numbers later on. The other things are now considered branches. So this one is a carbon branch. What do you call this carbon branch? What's the name for this?
Ethyl.
Okay, so that's 2 carbon atoms. This one is going to be eth with a Y at the end. And I've got a hydroxy. And I've got an NH2 as well. That's an amino. That's an amino group. So I've got 3 branches, and they should be named alphabetically. So I'll start with let's say start with amino. So I've got 3 branches of amino, and there's I've got 4 branches actually. Need 3. So I've got amino, I've got ethyl, and then there's alphabetically there's hydroxy. And there's 1 each of them. Now we're going to start numbering them. Let's start on the left side. Amino is at position number 5. Ethyl branch is at position number 2. Hydroxy is at position number 6. And then the EN is at position number 3. And the oic acid, no need to write that. It's at position number 1. So that's how you're going to name the molecule. Is this clear?
Yes.
Yes, sir.
Okay, so don't go into a lot of detail. I mean, there's a lot more detail in IUPAC nomenclature. But no, I mean, that's about it. I mean, no need to go further into too many rules. And I mean, there are too many rules actually. So we're just going to keep this up till this point. That's it. Okay, and we're going to stop our naming at this point. We're not going to study naming anymore. Any more rules, any further rules apart from this. So I'll just do one more example. So let's say I have this molecule. It's got a carbon atom. It's got another carbon atom. And there's an OH attached here. There's a double bond, and there's there are 2 halogens there. This one will have 3 H's, 3 H's, 2 H's. This over here will have 1 H. That's it. So first thing, let's quickly try and do this. Main chain should have the maximum substituent groups, the most important groups. So I'm going to bend in this direction. That's going to be my main chain. Should be a continuous carbon atom chain that has maximum things attached to it. That's this one. Because remember, the OH should be attached to it as well. Is that clear, main chain?
Yes.
Yes.
So anyway, so it's 4 carbon atoms, right? And who's the most important group in this in this entire molecule?
The OH.
The OH. So it's going to be an all. Like this main suffix would be an all. So this is 4 carbon atoms, but, en, and all. So it's a butanol molecule, and the OH is at position number 1. Because that's the most important group. So this is number 1. This is number 2. This is number 3, and this is number 4. Don't worry about if it's bent or not. I mean, it doesn't really matter. It's just think of this as the main chain. It's 1, 2, 3, 4. So you've got the double bond at position number 3, and you've got the other things are now branches. So you've got methyl branches. So that's 1 methyl, another methyl, and you've got chlorine branches, Cl and Cl that are attached to it. The OH is already part of the main chain, so you don't have to consider it as a branch because you named the whole molecule after this. So you no longer consider it as a branch. So the methyl or chloro, I think alphabetically comes first. So you've got chloro and you've got methyl, and both of them are two branches. So which is why it's going to be dichloro and dimethyl, because there are two of them. And you have to give the position of each one of them. So the position would be the chloros, both chloros are at 4. So it's going to be 4,4 dichloro. And both methyls are at position number 2. So it's 2,2 di. It's going to be 2,2 dimethyl. Both of them are at 2, so you're going to number both of them. One is at 2, the other one is also at 2. Both chlorines, one is at 4, the other one is also at.
Sir,
Yes.
why is it 1 4 dichloro?
Which one?
Over your dichloro, you've written 1 4. Or is that?
No, sorry, that's 4,4. I mean,
Oh,
that is like, if I zoom in, then that's 4. Okay.
okay. My bad.
So it's 4,4 dichloro, 2,2 dimethyl, but 3 in 1 ol. So is this clear? This thing?
Yes, sir.
Yes.
So I'm just going to give you an assignment. That's about it. That's naming we're going to do. We're going to practice more of it as we continue, but we're going to start studying the main topic now. Just remember, naming is important. It's sometimes the whole direct questions, hardly any direct questions on this, but sometimes the whole question depends on the name of the molecule. Like if they gave you this and they started talking about reactions of this molecule and you don't know what that is, then you wouldn't be able to solve the question. So let's continue tomorrow, and right now I'll send you a short assignment on this. TK. Make sure you try and do that. So let's continue tomorrow.
Okay, sir, I just have one doubt. I think,
Yes.
yeah, not regarding this. It's because yesterday you took a class for the past papers,
Yes.
right?
Yes.
Yeah, so can we join that group as well for the past papers?
Yeah. Nini, I will. We'll be having past paper classes hopefully on Wednesdays and also on Saturday and Sunday. I'll share the timings.
Okay. Thank you.
Wednesday, make it 9 p.m. We'll have a past paper class on that.
Okay.
And we'll do only physical chemistry, right?
Sir, we can't do Wednesday, sorry.
Wednesday, what time are you
Mikhail
free?
and
What time are we free?
Mikhail and I, what time are we free?
We can do 5:45 or 6 maybe.
No, the problem is I'm like, I have physics tuition, so it ends at 6. It's from 5 to 6, and then after that, like I have to go somewhere. We could do somewhere like the same time we're doing it now, like 3:45, if possible.
Okay, so we'll do that. We'll do this time then.
Okay.
So, okay. Take
Okay, sir. Thank you.
care.